with the North Carolina Museum of Natural Sciences in beautiful downtown Raleigh. It's Science Tonight. Now here's your host, Chris Smith.
Good evening, everybody. Welcome to the show. Welcome to Science Tonight. I am your host, Chris Smith, from the North Carolina Museum of Natural Sciences. It is good to be with you one more time for our actually final episode of Science Tonight with Chris Smith. Can you believe it? We made it. And in the not too distant future, we're going to be bringing a program just like this back in person at the Museum of Natural Sciences. Don't worry, there'll always be a virtual component. So if you've gotten used to tuning into the show on Thursday nights, you won't miss anything. You'll still be able to come right here to the museum's YouTube channel and check out our evening program. But this all virtual from the inside of, my work from home studio show, this is it. Listen, it's been a pretty incredible ride over the last however many months. This show, we started out as the Virtual Science Cafe, transitioning the great pivot, one of our in-person events, into a virtual offering. So we just called it the Virtual Science Cafe. But then we thought that's kind of selling what we're doing here short. Let's make it its own big brand new thing. I got a blazer. We called it Science Tonight. We got the cool show open. And it's been great to talk to so many amazing experts, guests, panelists, people doing interesting stuff out there in the world of science, technology, engineering, and mathematics. And great thing, this will remain on the museum's YouTube channel as a resource. So anytime you feel like learning something new, you can come right back here to the museum's YouTube channel, check out the Science Tonight playlist, and catch what I felt like were great conversations with some just really fantastic people. So this is the last thing for a Thursday night from me for a few weeks. But of course, we're always innovating at the Museum of Natural Sciences, always looking to bring you great new stuff. So that's why you want to be subscribed to the museum's YouTube channel. You can click subscribe right down there below the button. If you're watching on Facebook, you can click to follow along and get live updates from us. That way, you know when we're bringing you the next great live stream content out of the Museum of Natural Sciences. It also helps if you click the little bell to get notified. Bing. Okay, you want to do that. Now, of course, like we've done every other week so far, I've got a great guest for you tonight, and one that I'm very excited to have on for the final episode, too. I think we're going to have a great conversation. We've chatted a little bit, and I came across this person's work online where they've already been doing some really fun science communication around atmospheric science and atmospheric chemistry. So I hope you're excited to get a little bit of insight into why you need to know about the atmosphere and what's going on in the atmosphere through some of the interesting research of tonight's guest. I'm going to bring the guest on in just a moment. Before I do that, I want to remind everybody that as we go throughout tonight's program, if you have questions, if you have comments, make sure that you drop those into the chat and into the comment box as we go throughout tonight's program. Later in the show, I'll be reading your questions and thoughts out loud to our guest so that I can bring all of you into tonight's program and we can have a conversation, a little bit of a dialogue about tonight's topic, dusty clouds in the rainforest, which I didn't really think about there being very much dust in a rainforest. But guess what? I'm excited to learn, and I hope you are too. Now, I already kind of gave this stuff away a little bit, but tonight's guest is Dr. Carlos Valle Diaz. He's an atmospheric chemist and teaches at Coastal Carolina Community College. He also has just a great new YouTube channel called Aerosols, which I will be dropping a link to in the chat a little bit later, and I'm also going to put it into the show notes. Dr. Carlos, welcome to the program.
Hi, thank you for having me, Chris. Thank you. I'm excited.
Yeah, I'm glad that you could be on the show. It's going to be exciting to talk about your research, or the research that you did, dusty clouds in the rainforest, but also a little bit about your science communication. Tell us all, where are you broadcasting from virtually right now?
Well, I am my house in Jacksonville, North Carolina, which is at the northeastern section of North Carolina, like 20 to 30 minutes from the beach. That's where I'm at.
Oh, okay. Wow. I'm surprised you're not just broadcasting like from the beach. Why not?
My Wi-Fi doesn't go that far.
Very, very good point. So, okay, folks who've been tuning in for a little while know that the way I like to start out Science Tonight is by getting to know our guests a little bit, by asking some questions that are not at all, maybe they could be, but I don't intend for them to be related to the science. I call it the non-science questionnaire. It's not nonsense, it's just non-science. Carlos, do you feel up for a little get to know you segment?
Oh, totally. Let's do it.
Okay. Now, everybody watching at home, you can also drop your answers to some of these questions in the chat as well. And if you think Carlos got the wrong answer, you can let me know too, and I'll report back. So, first question for you: is a picture worth 1,000 words?
It depends on the person describing the picture. Because if a picture has a lot of history behind that shot, so depending who is telling that story, whether it's the person that took the picture, the person that, or the people that were part of the picture, they can definitely describe the picture in 1,000 words. But somebody that just passed by and just looked at the picture, probably won't be able to describe much, unless that person, I don't know, it's like a historian and loves to improvise a story when looking at a picture.
Wow.
Oh, okay. Okay.
Yeah.
Very, very nice. I'm gonna go ding. That's the correct answer.
Thank you.
Okay.
Yeah.
Next question. Does pineapple belong on pizza?
No. So I don't at all eat it in a pizza, but I'm not against people who do it because I eat certain Puerto Rican food that is culturally not acceptable, but I don't care. So, so people that are eating their
okay.
their pizza with pineapple are probably saying the same thing. Like, I don't care. I like it. Tastes good, but I wouldn't do it.
Well, I'm curious. Foods, I guess, here in like the contiguous part of the U.S. that we don't eat that are popular in Puerto Rico.
Oh no! So every country has its own cuisine, right? So there's one that we eat during the holidays that is called a pastel, and then some people like to put ketchup on top of it, and some don't. And people that put ketchup on it, then they're kind of made fun of, and they say like, "Oh, you're not really like Puerto Rican, or that's a crime." And I'm like, I love my ketchup and my pastel, so.
Wow. Okay. Well, look at that, everybody. We got educated on food controversies in Puerto Rico.
Yeah, but
excellent
so
stuff.
I don't fault anybody.
But that is the wrong answer.
Oh, really?
Unfortunately, that is the wrong answer. Pineapple absolutely belongs on pizza. Okay. Next, I'm joking. No,
I know.
Because I like it. Okay. Next question. Besides your current job teaching chemistry at Coastal Carolina and as a science communicator, if you would call that a job at this point still, what other job or career could you see yourself doing?
Well, I always wanted to be like a handyman because I always admire people that construct and fix things. And I wish I was that type of person, but I was always the academic. But I get along with a lot of people that are very smart through their hands. They construct, they fix things, and I like learning from them. So in a different universe, a different Carlos, I would see myself being a handyman. Yeah.
Excellent, excellent. Ding, right
Yeah.
answer. That's
Yeah.
excellent. Okay, next question. What number am I thinking of?
Okay. Well, what's your favorite number? No.
Okay, that's a good
Well,
strategy.
yeah. Do you like single digits, double digits, three digits?
Carlos, I've asked lots of people this question. They all just went straight for a number. You're the
I'm
first
just
one who's ever
investigating.
turned it around and tried to ask me and to actually try to investigate what the answer to this one could be. Okay, my favorite number is 3, and
Oh,
I do prefer single digit numbers.
okay. There you go. Okay, 3. So you like everything like 3, like it triangles, average data of 3. We always love getting 3 data sets before making an average.
There you go. Exactly.
Yeah. Yeah.
So in that case, you've got some data now. What
Yes.
number am I thinking of?
Well, you said that you love the number 3 and you prefer single digits, so you probably like also multiples of 3, so maybe 6 and 9 as well. Who knows?
No one has ever tried to science this question out like you have, Carlos, and I appreciate it so much.
I always overthink everything.
Unfortunately, unfortunately, those are all incorrect. I'm sorry. And we move on to our final question now.
Yeah.
What's a weird fact that you know that you feel like nobody else knows?
Well, I can relate to when I lived in Puerto Rico and before I did my research that I'm going to talk about. I didn't know, even as a Puerto Rican, that the dust that comes out of Africa reaches Puerto Rico in the summer months. Also, when I was learning all about everything I did in my graduate research, how clouds are not pure water. They need tiny little particles to help them grow. So those were, for me, kind of amazing, life-changing fun facts. So I don't know if they're weird, but at least they were pretty cool to me. Yeah.
Yeah, I think those are amazing facts.
Yeah.
Those are perfect. And I mean, this idea that dust from the other side of the world travels and makes its way to Puerto Rico. I think, okay,
Yes.
I'm not going to get into that just yet. I'm going to tabulate the score here and announce that you received enough correct answers. Congratulations. We're going to put you into the Science Tonight Hall of Fame for the non-science
Thank you.
nonsense questionnaire. Everybody, thank you very much for playing. But now I've got to know more about these dusty clouds in the rainforest. So let's get into some of the serious science. Tell us a little bit about what your graduate level research was, but maybe tell us a little bit about you first, and then give us an idea of what it was you studied.
Yeah, of course. So I was born and raised in Puerto Rico for 30 years and been living here in North Carolina for 4 years. So you can do the math, how old I am. So I did my bachelor's in chemistry at the University of Puerto Rico. And then I did my PhD in analytical chemistry at that same university. And I applied my analytical chemistry to an atmospheric chemistry lab to study basically the atmosphere in the Caribbean. And I put the catchy title Dusty Clouds of the Rainforest because clouds with African dust in it on top of a rainforest. But the title of my thesis project was way more elaborate than that. It was called Brace for Impact, the impact of long-range transported African dust over a tropical montane cloud forest, to see in northeastern Puerto Rico. I oh my goodness, I went in blank. I murdered the title a little bit. I murdered the title a little bit, but it was pretty loud. Like, what was that impact on the cloud microphysics and chemistry in that rainforest? It was way more long, and that was not going to be a catchy title for this show. So I made it a little bit more engaging for people can have a little perspective of how stuff are found in clouds, and it's totally normal. It is designed as so in this planet. And I was at a field site around 3,500 feet or 1,050 meters above sea level. And I sampled cloud water, aerosols, rainwater, collaborated with researchers, both national and international. They brought their own instruments. We basically collected a lot of data together and to help build up this story of answering what is that impact when these aerosol particles coming from Africa interact with the cloud water droplets on top of this rainforest in Puerto Rico called the Yunque National Rainforest. And what does it do to the chemistry of the cloud water? Does it help to promote clouds? Does it help to promote more rain, or the complete opposite, right? Because you want to understand the implications that it has in terms of climate change, right? The strength of these dust events has it increased or decreased or stayed the same throughout the years? And based on those dust events, how will these ecosystems respond to it, where they need these cloud water and rain events in order to supply fresh water and maintain the biological diversity that is right there in the ecosystems? And there's one in Puerto Rico. And since Puerto Rico is part of the US, you can technically say that the rainforest is the only one in the entire US, including its territories. But there's like 50 to 20 more of these ecosystems in the Caribbean, and around 600 across the world, in basically latitudes where you have a tropical climate. So yeah.
Okay, fascinating stuff. Okay, so
Yeah.
kind of like you were mentioning at the fun fact segment, and maybe I'm starting to put this together now. Clouds are not just water. Clouds need something in the atmosphere to begin to form. There's got to be something else there. And
Yes.
so how do these massive dust storms or dust particles that get blown up in the atmosphere that travel at least as far as halfway around the globe almost end up
It travels across the
impacting,
Atlantic Ocean.
travels all the way across the Atlantic? And
Yeah.
that would impact then cloud formation in a place that relies on there being lots of clouds so that it rains.
Exactly.
What got you interested in this relationship to begin with? Did you like hear about an African dust storm and then start putting the pieces together? How did you land on this project?
Well, I was interested in doing field research because during my undergraduate studies, I did laboratory-based research. So you're basically modeling what's happening in the atmosphere, but it's not really like aligned with reality, in my view. So I wanted to have more field research, like actually go to the site and study it and understand the dynamics of the atmosphere in person. And so I knew about this laboratory and researcher who ended up being my thesis advisor. And I told her, I'm very interested in working in your lab. And she said, well, I have this study that is ready to be approved by NSF. and
Nice.
and it's called the Puerto Rico African Dust and Cloud Study, which is basically the study that I participated in and the meat of my thesis project. And I said, that sounds so cool, and I can't wait to begin. So that's pretty much how it started.
That's really great. So elaborate then for a little bit. what is the relationship? Or maybe, you know what? I should back up. Give me a little bit of insight into these African dust storms, how big they are, and how dust moves from the Sahara Desert to the Caribbean.
Oh yeah. So have you heard about the trade winds that carry basically the hurricanes across the Atlantic Ocean and through the Caribbean and the U.S.? So those trade winds also transport these African dust particles. So in Africa, you'll regularly have these dust storms that basically pump up all those aerosol particles into the air. And then the trade winds will carry it through the entire Atlantic Ocean. And it takes roughly about a week for it to travel. And this image that you're seeing right now, it's basically an artistic painting, if you will, but it's not really made by an artist. It's generated by a model simulation to kind of help visually demonstrate all the types of aerosol particles that are across the globe, right? It's a very natural process that is very important in the earth, because aerosol particles not only are part of the cloud formation process, but depending on the types of particles, it can also provide nutrients on the oceans, on other ecosystems, right? And the one that is highlighted there in orange, that's the African dust. And on the farther right is the dust from the Gobi Desert in China. And in the lower right, you have from Australia also pockets of dust events. And as it travels through the Atlantic Ocean and reaches the Caribbean in the summer months, because in the winter months, that dust arrives to the Amazon forest and it supplies nutrients to the Amazon forest. So believe it or not, the Amazon forest and Africa are friends. They need each other in that regard, right? And you have the blue and white aerosol particles. That's basically sea salt, marine aerosols across the entire, all the oceans, right? And we have a lot of those aerosol particles around Puerto Rico because it's an island surrounded by water. You have the green ones, which are basically biomass burning aerosols. White that you see across the US and Asia and some parts of Europe. Those white aerosols, they're basically labeled as anthropogenic aerosols, as man-made pollution. So yeah, and it's a nice visual way to showcase how these aerosols are present across the globe, and how the winds carry them and the impact it can have both on health, economy, flora, fauna, both positive, negative, and the chemistry that governs all these processes and its relationship with the climate.
I never would have thought that dust from the Sahara had such a global impact on so many different systems. And I'll say, when I first saw that image that was just shared, I thought that was a satellite image, or like a composite satellite image. Did you say that was actually a model of aerosols and particles moving around? So how do you actually track African dust then?
Oh, good question. You can track it through satellite images, usually. We can also predict the presence of it through instrumentation, forecasting models, and such. But usually, a satellite image is a way to appreciate it. And I have a picture that shows a dust plume being ejected from Africa, which is the next picture. I don't know if you already have it there.
Yeah, it should be coming right up.
Yeah, sure. That one. So that is a satellite image. You have there Africa. Sahara is where you have the dry region. That's where you get the majority of those dust storms. And how you see that dust plume, like consider like a sneeze, right? Just throws that dust all across the ocean for us to receive it. So yeah. And in the next slide, I have pictures of how it impacts the visibility in Puerto Rico. So there's a red arrow pointing towards Puerto Rico. Puerto Rico is very small. From one side to the other, you drive 3 hours and a half. So it's a very tiny island. And you can see
Okay.
that brown smoke. It's not smoke, it's a brown dusty haze across the country. And then you can see Puerto Rico with clear skies and clouds. But once the dust events arrives, you basically can't see the sky as much. And when I travel to Puerto Rico or leave Puerto Rico, when you take off or land at Puerto Rico, you can see that dust layer as you go. It's pretty cool.
Oh, I mean, these pictures are fascinating to me. The impact that it has on the entire landscape of the island. So when you were doing your research, then I guess it's kind of simple then to look at the satellite, or not simple, but you can look at the satellite imagery and I guess maybe even look outside and know if you're experiencing one of these dust events.
Oh yeah.
And so then what would happen next? Do you like run up the mountain and try to start collecting clouds? What's the next step in a project like that?
So that is a very good question, and that would be really cool if I had like a house like right at that research site, and I live like isolated from society. That will be a way to approach it. But usually what we do, and it's how I did it during my time there, you plan out a field campaign. So you say, and depending on the amount of researchers that are going to be there, the time frame can be adjusted. But you can be like a month or 2 months, 2 weeks, depending on the resources and the objectives of the study. Just say, okay, we are going to set up all the instruments here, and we're going to be working and collecting data whether we have dust events or not. And since we know that during the summer months is where we get the majority of those dust events, then we will plan our field campaigns in our summer months. If we want to compare where there's no African, and that campaign, you're basically preparing yourself for a very long quote unquote vacation when you're planning something for the long term, because I just basically drove up there every single day to collect all my samples, data from other instruments that I was also responsible for. And as a host to researchers from outside of Puerto Rico, I would also collaborate with them and make sure their needs were met as well. Because, we were kind of the institution responsible to host these people as well and make sure they had everything they needed.
Very, very interesting. Okay. So you've got dust. You launch a field campaign. You've got instruments set up to collect water. Are you trying to gather dust? I don't know how you like grab a cloud. I don't think of clouds as being like something that you can just grab and sample. So how does that work?
I'll show you. So I'll show you that in a couple of pictures ahead, but it's technically like a vacuum cleaner. So imagine that you have this like hollow cylindrical tube and you put some Teflon strands, and then you put a fan that will aspirate that air. Because when you're inside that cloud, it's basically a very wet and windy area. So let me see if you already pulled that picture up. Let me see. Yeah, perfect. So the picture on the right collects all the cloud water. It collides with all those Teflon strands. On the left, you can resolve it by size because cloud water droplets differ by size. And the chemistry can depend on the size of that cloud water droplet. So it'll first collect larger cloud water droplets, in average 17 micrometers, and then 4 micrometers in the in the second stage. And there's also cloud water collectors that can resolve even more size ranges. And this is an active way of collecting cloud water. There's a passive way where you can basically put like a net of a lot of Teflon strands and have just the wind with the water droplets collide on it, and then through gravity you collect it. Actively, you basically run that fan and collect it a little bit quicker because we want to collect multiple samples a day to kind of see if there's a difference also between in the morning and during the day. We weren't allowed to sample at night, but we could have done that as well. That's pretty much it, yeah. And in that picture, you can see this white, hazy background, and that's basically a cloud event, right? And I have a picture where you can compare the research site at 3,500 feet, where there's not a cloud event, meaning that the cloud layer is usually higher. And when the cloud layer is around the level that you're at, and you cannot see anything. No, next picture. That one. Yeah. So when the clouds basically lift off and I can't collect them anymore, I have this amazing view. But then the clouds go down, usually in the morning at night, and you can't see anything. And then you start getting wet all over because of all those droplets hitting you, and it gets like kind of windy and cold. So it's pretty cool. It's pretty cool.
Wow, that view is gorgeous.
Oh, yeah. Totally worth it.
Although it also seems like it would be pretty cool to know that you're inside a cloud, which I guess that's what fog is if you're just walking around on a foggy morning. But it seems more exciting if you're high up in the sky with a cloud.
Oh, yeah. It's more wet and more windy than a fog. Because in a fog, you're like, oh, okay, it's just fog. But in a wind, you're like, it's more crazy. And you end up with tiny little droplets on your hair and everything.
Very, very cool. Well, so tell me what you learned then. What do we now know about dust events reaching Puerto Rico's rainforest?
Well, basically, and part of the first part of my study was to prove that I was receiving African dust. Yes, we know that we're receiving African dust, but from a scientific perspective, you have to prove it. And you would use a multitude of resources: satellite images, forecasting models, chemical data from your samples that can be related to sources, whatever the National Weather Service could provide to help corroborate your findings. You will use multitude of all those resources to kind of prove, like, during these days I was receiving dust events. During other days I was basically receiving more background marine aerosols, and other days we would receive either anthropogenic pollution from the neighboring southeastern islands. And in the winter months, when you have those cold fronts coming from the US, you would also get the pollution from the mainland as well. So that's how you would track these events. And then with the data that you collected, then you would group it by those periods and then average everything out, or do like a time series or anything that you need to do. And then you can compare, like, oh, during dust events, this happens to the chemistry and the physics of clouds. During non-dust events, basically marine background aerosols, you get these results. When you have pollution coming your way, what does happen? So that's how we kind of approach the method of comparing what happens to the clouds in the case of my study.
Interesting stuff. Very interesting. I mean, I guess I'm a little bit familiar with atmospheric sciences. I mean, I work at a science museum, right? We're kind of surrounded by all kinds of different sciences, but you're talking about some like very fine scale interactions that then get magnified into global scale or partial global scale ecosystem
Mhm.
interactions, like whole biome interactions. So, what do you find is the most, to you at least, interesting piece of that? Is it like the impact of, the cloud formation on the rainforest and biodiversity? Is it how the individual aerosols and particulates in the atmosphere form clouds? Or as an atmospheric chemist, is it even smaller than that? Are you even more interested in looking at like, elemental composition of clouds and things like that?
Well, that was a good take of everything you said. To answer my question, all of the above, because that's pretty much what I did. That's pretty much what I did. I was looking of the chemistry of the cloud water. I would see like, oh, look at these elements that I'm detecting. These ions, these metals, the this organic material, and find how it changed during these events. I would notice how cloud water droplets, the concentration in terms of amount, the size of the cloud water droplet, how much water did it contain, change during these events. So I get to appreciate uh, basically how aerosols really do impact at a fine scale the cloud microphysics and chemistry, and what implications it could have in terms of precipitation. And that part, I did it through modeling in collaboration with the National Center of Atmospheric Research. And that was quite the learning curve for me because I'm not a modeler. And that is very different than working in the field, which is where I believe I thrive more. But we could also
Sure. Sure.
corroborate through modeling research that does is plays a role in modulating precipitation, but it still remains an open question if it hinders it or promotes it. But it definitely plays a role in affecting precipitation. Yeah.
Okay, interesting. So we actually don't have all the pieces of this aerosol dust puzzle put together just yet. But you're saying it
Yes,
can impact precipitate. We think it can impact precipitation patterns, and I'm thinking that also impacts so many other things like climate in whole regions. So our
yeah,
aerosols are kind of like a big question mark in a lot of fields like that.
great question. And that enters into one of the chapters that you see in the assessment reports in the Intergovernmental Panel for Climate Change, the IPCC reports that we talked about it previously together before the realm of the
Yeah.
IPCC. Yeah, and
The
so
big
there's
climate report.
the big climate report, and there is a general consensus of the role of greenhouse gases because they last longer in the atmosphere. You can have as short as methane that lasts 10, 12 years versus CO2 that can last hundreds of years. So it's easier to understand the implications that greenhouse gases have on climate. Aerosols, they last for hours, weeks, and days, not years. So aerosols depend also where they're being formed or emitted across the globe. It depends on the place of origin, the meteorological patterns, the types of clouds, and it is constantly being transformed. So that increases the uncertainty of their role, if it's positive, negative, or ambiguous, right? There are estimates that it makes a cooling effect in contrast to greenhouse gases, but there's also data to support that it also helps increase also that radiative input that increases heat, and that depends on the type of aerosol, um, and also how long is it in the air, how was it being processed. Like it's a lot. It's a lot, and it's a very active area of research, and it's called aerosol cloud precipitation, uh, or aerosol cloud interactions. I said aerosol cloud precipitation because the aerosol, once it forms a cloud, then eventually falls out as rain. But the more accurate term is aerosol cloud interactions.
Okay. Oh, wow. Okay. This stuff is blowing my mind with how
I'm glad. I'm glad.
like important it is, like how big of an effect that it has, but also how I don't want to say complicated, but yeah, complex. It's like an onion. There's just so many layers to peel back to try to understand how all of these processes work together, and then have this seemingly pretty critical role in things like climate and in global
Yeah.
ecosystems. That's really exciting.
Yeah.
Okay,
big
folks who are watching. Oh, well, I was just going to say real quick, folks who are still tuning into the show, glad that you're here. We're talking with Dr. Carlos Valle Diaz, an atmospheric scientist at Coastal Carolina Community College, about dusty clouds in the rainforest. And in just a moment, we're going to transition over and start getting your questions. So there are already some great questions, like really good questions. One of these questions is the bomb. That's important.
The bomb.
That was a joke.
Yeah. Okay.
Get ready. There's a good question in here for you about bombs. And so that's a bad joke. Okay. Well, you can be noodling on that one. But I also, Carlos, want to talk about your YouTube channel and your science communication work on Instagram and on TikTok, because I've seen some of these and it looks like you're doing some pretty fun and interesting stuff on social media. Like amazing stuff, great stuff. So give everybody the scoop on what's gotten you into doing videos and stuff on the web.
Yeah, it's a funny story because I still can't believe it to this day, right? Because I was raised in the academia. So you live in this bubble, like you're just straight going to do postdoc and then do research and be a professor at the university. But I realized in my last years, I wanted to be a communicator. I felt that I wanted to engage more directly with the public rather than just publishing and writing proposals, which obviously is meaningful to the scientific community, right? But I wanted to be more of the messenger and learn as I go and be more freelance about it. So I've gotten to watch a lot of science communicators in YouTube, and that spark just kept on going. So eventually I decided I'm going to pursue this path. And I had to break my thesis advisor's heart. I said, "Oh, I'm not going to do a postdoc." But but you've been amazing, and you'll be in my heart forever. But I got to move forward. And so I went through a humongous learning curve because I had to teach myself a lot of how to make and edit videos. I underestimated how hard it was. So once I started last summer during the pandemic, I started on YouTube, then I started growing my Instagram, and then I went into TikTok. And through TikTok, I want to make like quick, informative, and funny videos. And YouTube, I want to make more comprehensive discussion of topics, because I noticed with all the science communicators that they don't have specifically one about atmospheric sciences. And there's not a lot of diversity in terms of skin color or country of origin, sexual orientation, everything. It was very like one note, like science was before.
Mm-hmm.
So I wanted to
Right,
include
yeah.
myself there to add a representation. So all of that kind of cooked in my mind, and I said, I want to be a science communicator in the atmospheric sciences, and I'm going to add representation with everything that makes up me. And I've gotten to explore my creative side because I've always been very creative. Even as a scientist, where we're very left brain, I'm very left brain, and you noticed that when I was harping in on your number that you were thinking about. So, but I'm also
Right,
very right
okay.
brain because I like doing cosplay, Halloween. I always enjoyed making artsy projects. So, and also like communicating with people through different means, interviews and everything. So I said, you know what? I'm going to do it. And it was a lot of learning curve, a lot of self growth, and slowly but steady, I'm building something really special. Yeah.
I'm like, big round of applause, because I think that's incredible. Not only like, no, if somebody had said, and I work at a science museum. I do live stream web shows for the museum all the time, and I meet a lot of scientists and science communicators in, my job at the museum. And if somebody had said, hey, I want to learn more about clouds and the chemistry of the atmosphere, or maybe just about anything related to atmospheric sciences, perhaps, maybe I could have pointed them to some individual videos where some science communicators like took on a topic. But I couldn't. Now you're the only one that I can think of who's thinking about the atmosphere specifically as something that is important for people to know about. And I think based on the research that you were sharing with us, like, okay, yeah, it makes sense. People should have an understanding of how these systems work on a regional or global scale, because they impact so many other aspects of what we're dealing with, things like changing climate. And then I definitely could not have pointed out like a Latino scientist doing very much science communication out there at all. They definitely are out there, but like you indicated, the level of diversity is not there compared to science communicators who look more like me.
Exactly. And of course, all voices are valid, but when you're seeing a specific voice all the time, it doesn't give the full scope of how broad you can take science from different points of view. Even though science is supposed to be objective, but also there's also some personal, cultural, and additional layers attached to that makes one's voice unique. And I do, in the long term, I do want to be a resource that people can look up into YouTube. Like, I want to learn topics about the atmosphere, right? Yes, there are science communicators that discusses those topics, but it's not a channel dedicated to that topic. And I want to be that person. And slow but steady, I'll get there. But being a science communicator and creating content is really challenging. But I love it, which is the important thing. Because if I didn't, I would be like wasting my time. But if I'm still like on this path, I know that this is going for the long term.
Excellent stuff. Okay, just one more question for you. I saw this on your Instagram, but I haven't gone and looked it up on TikTok yet. Something to do with nose hairs and atmospheric science. And I don't know what this is about. And maybe you should tell us. Everybody should just know that there's a video about nose hair and this very dramatic Instagram photo that you put up where it looks like, I don't know what's going on, but it looks very exciting. Maybe painful.
Actually, it wasn't. It wasn't. So it was a nose
Okay.
hair removal kit that you would like pluck in wax inside your nostrils. So I recorded a TikTok to teach that the importance of nose hairs, because of course we live in an image conscious society across the world, and there's this rave about nose hair removal through waxes, and I wanted to give a perspective like we're constantly breathing aerosol particles, and nose hair is like a filter. So removing those nose hairs, it has been linked to an increased risk of developing asthma. So I wanted to link the concept of aerosol particles with something fun. So what I did was I literally did it, and I plucked it, and then and, and then I basically said no, use nose trimmers and scissors instead. So it was a way to be funny but educational at the same time. So sometimes you'll see content of me more on the serious informative side, and other you'll see my more kooky and eccentric side. So I'm a little bit all over the place, but that I love myself for it.
That's amazing stuff. I also just liked. I saw on Instagram, maybe it was a TikTok. I guess it was a TikTok. You shared it to Instagram too, of just calling out the elements that spelled the word inclusion for Pride Month. I was like, look, that's just like it. Just that it's short, it's sweet, but just gets such a cool message across too. Like science and inclusion
Yeah.
go together.
Oh yes, and this month is Pride Month, so I was like, I need to do something for Pride Month, and also for me as a gay person, so it fits all perfectly together. So I saw this T-shirt that said inclusion in the using the elements of the periodic table, and then I was like thinking, I want to do a TikTok on this. And it said, the teacher said, inclusion is elemental. So I did my own take on it. So I said, okay, I'm going to teach about the elements because I'm still a chemist, and then make something fun out of it for Pride Month. Yeah. Well, I'm glad I have a fan. I'm glad I have a fan of all my content. So that's great.
You got at least one. Okay. Let's see. I'm blown right through my time. Matt, let's go ahead and roll the clip from Carlos's YouTube channel. Give everybody just a little bit of taste of what they can find across Carlos's science communication channels. And when we get done with the clip, everybody, we're going to take your questions. Okay, so we might not have audio on the video, unfortunately.
Oh, that's totally fine. I can describe it. I was basically showing how clouds are formed and that aerosol particles are important. So I use rubbing alcohol to saturate inside the bottle with a more volatile gas instead of using water. And I put in the smoke coming from the incense because, believe it or not, those smoke are aerosol particles. So then you lock it into place, and then you increase the pressure, which mimics conditions right here on the surface, because you don't have clouds here necessarily on the surface. And once you release that pressure, it mimics the clouds up in the sky where there's less pressure. So then those alcohol droplets, in that case that I use, they will condense on those aerosol particles and make a cloud, quote unquote.
Excellent
Yeah, the
stuff.
title of
We've
that
done
video
that. We do
is
that
Cloud in a
demo at the
Bottle.
museum. Sometimes.
Ah, that's
Cloud in a
cool. That's
bottle.
cool. Yeah.
All right. Well, sorry the audio didn't come through on that one just right, but
Don't worry.
everybody, you can go check it out and get the good atmospheric science content that you all need. Okay. Few minutes left. Plenty of time, though, to get through some of these questions. So, Carlos, let's see what the people are thinking. First off, you've got a huge fan club of people who are sharing emojis of the Puerto Rican flag and like flex arms. So there's a whole fan club here in the chat for you.
I invited a lot of my family and friends. I had to. Latinos, we do that. We
Absolutely.
need the crowd.
I'm so glad that they're all here. Okay, first one. If there is nuclear detonation, do those particles also travel through the atmosphere?
Well,
So
the
nuclear
detonation.
fallout.
Yes. So one thing is the smoke and the aerosol particles that come from it, and the radioactive elements that are embedded. So if those radioactive elements are embedded into those particles, then yeah, those elements will travel across using those particles as a car, if you will, while the wind travels it around. So that's one way of looking at it.
Okay, there you go. Check, yes. Okay, let's see. Are bacteria, fungi, and viruses found in these aerosols?
100%. 100%. So, the pollen that we receive in the US, those are aerosol particles because they traveled and eventually deposited. So that's what we call the cycle of an aerosol. It has a lifetime. Once it comes out of the atmosphere or made in the atmosphere, and eventually either falls off or is involved in the formation of cloudwater. And bacteria, fungi, and viruses have been found in these aerosol particles. We call them bioaerosols. So not only you have the pollen that travels, in this case across the US, but you also have the ones that you can find in cloudwater and ice clouds. They have been detected there. Mm-hmm.
Okay, so just about anything very, very tiny can get hoisted up into the atmosphere and just hang out.
If it floats on the air, it's an aerosol.
So many things, so many small things. Okay, let's see. How does this affect agriculture?
Which type of particle? Any aerosol particles?
Let's see. I think this question came up when we were talking about African dust.
Oh, wow, good question. Well, I can at least answer that. And for the Amazon rainforest, African dust supplies iron and phosphorus that is found in African dust. So you can kind of see it in, like being a fertilizer. And that type of fertilizer also fuels phytoplankton blooms across the Atlantic Ocean. So it has that effect. I don't know if it had a negative effect when it deposits in other forms of crops. So that part I owe you, but I do know that it positively influences, like for example, the Amazon rainforest and the ocean for phytoplanktons.
All right, excellent. Okay. Are there estimates of how much dust in terms of weight is being carried in these aerosols per year?
Yeah, great question. Thank you. And I'm glad I know the answer because I was reviewing my thesis because I finished 4 years ago. So things leave your mind. So it is estimated across the world annually from 800 to 3,000 teragrams. Teragrams is equivalent to 1 million metric ton. So, and a walrus approximately weighs a ton. So if you put 800 million to 3 billion walruses and spread them across the sky, that's the amount that the dust
Yeah.
is in the air, and you travel it through the entire planet. Yeah.
There you go. 3 billion walruses worth of dust traveling through the sky.
Yeah.
That's some
Mhm.
art. Somebody needs to draw that, paint that,
Oh
tweet it
yeah.
at the museum at Natural Sciences.
Oh yeah.
All right. Let's see. Can one determine the forecast of large storms due to atmosphere impacts in America, in Africa?
Like forecast the dust
Can one
storms.
determine, not in America, excuse me, can one determine the forecast of large storms due to atmosphere impacts in Africa? So I guess can
Like
you
forecast,
look, like take a dust storm in Africa and then say, in 2 weeks there's going to be rain in Puerto Rico?
That is a good question. I don't know if there's a conclusion to that, but I do know that it brings a lot of dry air, and it gets really hot when in Puerto Rico. But if it's related to like increased precipitation drought, that I'm unclear, because there's data suggests both. I do know that dust storms, when they're mixed with hurricanes that are being formed in the Atlantic Ocean, to my understanding, it can help in suppressing the intensity of the hurricane.
Oh, okay. That's
Yeah,
interesting. So the dust
yeah,
tamps it down a little bit.
yeah. To my understanding, yes. I'm not 100% up to date with that information, but I know that while I was in conferences and learning about that topic, that's kind of what was suggested. Mhm.
Well, that's an interesting nugget for your next cocktail party, everybody.
Literally.
Okay, let's see. Leslie wants to know, when the moisture goes into the collectors, can you see the dust? Can you touch it? Is it gritty feeling?
That great question. So when you have dust events and you collect that cloud water, there's an orange, brownish orange color deposit, and that accumulates in the bottom of it, and you can filter out that water if you want, and you're going to see a nice orange film across it. Yeah, you get to see the dust. Yeah.
Very interesting. And another viewer here wanted to know about anthrax spores being carried as aerosols.
Well, I mean, if you can aerosolize it, then I guess makes sense, because that I think that's how chemical weapons are designed as well. That when you did when they activate, you
Mm.
want them to aerosolize to travel, right? And even if they're technically not aerosols, or they're more like just gases, gases will travel with the wind as well, like because like the air that we breathe is mostly nitrogen and oxygen. Those are gases. So whether it's whether it's technically the definition of an aerosol, which is a liquid or solid particle suspended in the air, or a gas, um, it can travel as long as you have some wind.
Wow.
Yeah.
Okay. It looks like a couple more here, and then I'll let you go since we are over time. Oh my gosh. Okay. We talked a little bit about this, but how do aerosols affect airway diseases like asthma or COPD? And I might add, if
Oh,
you still have your nose hair.
I still do have my nose hairs because I only took away the surface for educational purposes, obviously. But yes, so they are small enough to go through your airways, and the smaller that they are, the deeper they go into your lungs. And the surfaces are not necessarily smooth and round, so they can do like minor like cuts and abrasions, to like irritate that area, and that can increase the risk for cardiovascular diseases, or if you're already prone to asthma, or in this case COPD, it can worsen those symptoms as well.
There you go. Great question on there. And then the last one that I've got here on my list, does this aerosol dust load in the atmosphere affect the climate in a large or notable way?
Yeah, so I was checking out the IPCC reports, and there's data that suggests that through scattering of solar radiation, it can help with cooling, but it can also absorb radiation and contribute to heating. So there's still like a large uncertainty on what is the net effect of African dust, or all the dust sources combined. How much does it help mitigate or enhance, or neither, if you will, relative to greenhouse gases? That's a good question.
All right.
Studying the
That's a
role
very good-
of these particles in climate is really, really, really challenging. The problem with the atmosphere, when studying the atmosphere, is that there's like thousands of variables, and you can't control them. The Earth is what it is, and errors and uncertainty is very common in this research.
Well,
Yeah.
Carlos, this has been fantastic. Thank you for taking so many of my questions and taking so many of our viewers' questions as well.
Thank you. I had a great
Very
time.
enlightening stuff.
Yeah.
Give everybody an idea. Tell everybody where they can find you, how to find your YouTube channel, and how to find you on social media.
Yes, so you can find me on Instagram, Twitter, and TikTok at Dr. CJ Valle Diaz, DrCJVALLEDIZ. And on YouTube, my channel is called AirPsych, AIRPSYCH.
And all of that information is down in the video description right down below here. If you need to look at it again, put your eyes on it. Go visit,
Thank you.
check out the videos, and hey, yeah, everybody, go support a great science communicator in the space. Carlos, it is fantastic to meet you and have you on the show tonight. Thank you so much. Everybody, thanks for tuning in to this last and final episode of Science Tonight. Hey, it's been great, but I'm still going to be at the museum, and I'm still going to be working with the museum and all of our great researchers, scientists, and the great big science community that we have to bring you more great science content, all the stuff that you know and love to hear about across all different kinds of disciplines. Looking forward to what's going to come next. Make sure that you are following the museum on social media. We're at Natural Sciences on Facebook, Twitter, and Instagram. And you can, of course, right here, subscribe to the museum's YouTube channel. That way you will be ready when the next great thing comes out of the museum. Of course, we have great things coming out of the museum across all of our different departments every single day. So you'll do good with a follow on social media and a subscribe right here. Great stuff happening all the time. Thanks again, everybody, for tuning in. Take care, stay safe, keep your community safe. We'll see you again next time. Bye, everybody.